Hello and welcome everybody, this is Roland from graphicinmotion.com and it is tutorial time again. In this tutorial we will take a look how we can model some very funny abstract shapes for motion graphics in Houdini. If you take a look here at this pack that I have, I actually created 100 different abstract shapes that you can use for motion design projects. And I created all of these in Houdini using the full power of procedural modeling and volume modeling. So I will pick out a few of these and show you how to model them. If you want to get this whole pack and use it for your personal or commercial projects, you can do so. This pack is available on my Patreon, so if you are a full access member, this one here, then you have access to everything that is available on my Patreon. And here under the resources, you can find this pack and you can download it. So the elements are included as an FBX and also as BGEO files for Houdini. And of course, the original Houdini file that you can see back here is also included. And as I said, you can use them for commercial projects and of course also for your personal projects. The additional benefit, if you join me on Patreon, you can also watch my exclusive Well Playground course and all the video tutorials that I will release in the future. If you do not want to become a patron, you can also get this on Gumroad. So I will put a link in the video description, and here you can also get this pack of these 100 abstract shapes. But of course, you can also do it yourself. So let's take a look how this is done and let's jump right into Houdini and I will open a new project. Okay, now let's get started and let's create our first object. And therefore I will create a geometry node as always. And I want to create a cross out of tubes. So we'll call this my tubes cross. That's of course very basic, but just to show you the basic workflow that I used here. So first of all, I want to add in a tube here and I will just change some settings here. So let's add in a few more columns here. Let's press Shift W to see our wireframe structure. Let's add some end caps here and let's make sure that the radius is a little bit smaller, maybe 0.2. That's fine. Now I want to create a second tube to create our cross, and therefore I just add a transform node like so and rotate it 90 degrees on the Z axis. Now I select both of them, hold down Alt, drag down to merge them together. And you see I have a very cool tube cross. Wow, amazing. Now, how can we turn this into a smooth abstract shape? I want to use a method called volume modeling. So I will convert this object here, this polygon object, into volumes and then manipulate it and then convert it back to polygons. So let's do that. Let's use a VDB from polygons to do that. This VDB from polygons node will just turn your polygons into a VDB. A VDB is a volume. That means we are working with voxels now. So I do not want to go into too much details what that means, but you can research that if you're interested. Now, the resolution of this is defined by this voxel size here. So if I set this down to 0.02, for example, you see that I get a way better resolution. The only problem that I have here is now that these volumes always have a bit of a problem with these very, very sharp edges as we have them here. I want these to be smoothed out a little bit. But before I smooth them out, I want to show you what the result is if I turn this volume now directly into a polygon mesh. So let's use a VDB convert. Actually, it's called convert VDB, this node. Yeah, convert VDB right here. And on this node, you can turn this back now, this volume into a polygon, and you see this is the result. And yeah, the result is not really great because now I have these horrible edges here, these horrible problems of my geometry here. So this is not how we can use that. But what we can do is we can manipulate our VDB in between these two operations, and therefore I can use a VDB smooth. There are actually two versions of this. Most of the time I use the SDF because this is working on sign distance field. I do not want to go into these details now as well. So let's just take a look how we can smooth this out. You see that we have some different operation types and they smooth out your mesh in different ways, as you can see here. And in this case, I think this one is pretty good because it somehow keeps the curvature flow a little bit better and keeps some details even if the mesh is, it's not too dense. By the way, if you want to change the density of the mesh, you can come up here because this is defined by the voxel size that you put in. If I set this lower, then the mesh will get way denser, as you can see here, and it can get also really dense. So now it is very smooth, and you see that the edges are a bit more defined. But of course we have, let's see, how many do we have? We have about 30,000 polygons. So if I set this back to 1.5, now we only have 13,000. So a little bit better. So this way you can create a smooth version out of this. But the power in Houdini is definitely its procedural workflow. So now I can come up here and manipulate this even further. So let's say I want these tubes to be really tubes, because now they're just some cylinders, a cross made out of cylinders. So let's try to create tubes out of these. And how can we do that? I will simply grab all of these 3 nodes here, hold down Alt and drag them over. And now I just want to change the radius of these tubes here, of the new ones, and I just change it to 0.1. And I want to make these a little bit taller, so just a little bit. Now I have another cross, a second cross. Now I can create a boolean operation, so let's add in a boolean. And the boolean is really good in Houdini. And I want to use this here on my input A, this on my input B. And if I activate this now, you see it is set to the operation type subtract A minus B. So it will subtract this side here from this side, and we get this hollow object now, this cross of tubes. And if I feed this in directly into my VDB chain here, then you see what we got. This is the result now. We have a nice and smooth cross, tubes cross. So this is the basics how you can quickly model something using just a few primitives, maybe some bool operations, and then this volume meshing workflow. Let's take a look at another option that we have, and let's create another geometry node. This time I want to create a network. So let's create a net here. Let's dive in. And let's change this from ghost other objects to hide other objects so that we do not see the objects in other nodes. Now there's another option that you have when working with this volume modeling. You cannot only use polygons, you can also use particles. And particles in Houdini are exactly the same as points. So we can use points to do that. What does that mean? Let me show you this. So let's first of all bring in here a line. I will just create a simple line. And by default, this line has only 2 points. Now I can use these points to create geometry. So if I go in here now and say VDB from, and this time we do not select VDB from polygons, this time we select VDB from particles. And if I connect this now to my line, you will see what this does. It will create 2 huge blobs, and this has to do with the point radius here. So let's bring this down. And now you see we have 2 spheres. At some point, these will disappear, and this again has to do with the voxel size. So if you decrease the voxel size, then the resolution of the volume will increase, and now we can go even lower here and make these smaller. So to turn our line now into a real shape, we just have to increase the point count. So let's go to the line settings here and increase these points. And you see, the more I increase this, the smoother these shapes get. So I can do something like that, but I can also just increase this and increase this until I get a smooth surface, like so. And of course, now I could again come in here and convert this back. So VDB convert, or convert VDB, convert it back to polygons and turn off these points. And you see what I have. I now have again a mesh. And with that, you can of course also do very nice things. So let's check out, let's use a copy transform node, copy and transform, and let's put this after our line here. And let's create some copies out of our line. Let's say I want the total number of copies to be 4, and let's offset them a little bit. So let's see how we can do that. Oh, let's actually not offset them on all axes, but only on the x-axis. So I want to offset them maybe 0.25 could work. Let's take a look quickly. Now they're a little bit too thick, so I come in here and just change this radius down a little bit. Yeah, this looks a little bit better. And now I just want to create another copy of these lines. But before I do that, I want to make sure that these are actually in the middle of my scene so that I can rotate them. And therefore I use a match size node. This is a node that I really use a lot to just center something to the scene. You see, here you can just choose whether you want to center it. You can also use it to put something on the floor or on your ground floor by using minimum here. Then they will stand exactly on our ground floor here. In this case, I want to use center, and now I have this. Now I can just add in another transform. So that's pretty similar to what we did before. Let's add in another transform. Let's rotate this 90 degrees. And now let's merge these two together. So hold down Alt, create a merge. And if we take a look now at the result, you see we have a nice grid. And if I want this to be smoother, then I go to my VDB from particles. I reduce this resolution here, and I bring in a VDB smooth SDF here. So bring it in like this. And now you see I have very nice and smooth grid created. This is perfect, for example, for something like soft body simulations. Okay, so we already created two objects, as you can see here. And this is really fun. So you can really have a lot of fun with these things. I want to show you one more object now, one more technique, because I really like that one. So let's go in here, create another geometry node, and let's call this our Platonic, because we will have fun with the Platonic object. That's a really cool one too. So let's add in here a Platonic object, Platonic solids it's actually called. And what this is you can create different objects with this, and you can change the type here. You can choose this tetrahedron, cube, octahedron, icosahedron, and so on. So you can also use this soccer ball, for example, pretty funny, or you can use this Utah teapot. Yeah, that's also a very funny thing, but we don't want to use that now. In my case, I think I will just use maybe the octahedron for now. So what I want to do with this octahedron is I want to copy tubes to each of these surfaces. So how can we do that? If we take a look here at this object, it has only points on the edges here, as you can see here. But I actually want to have some points that are in the center of my primitives here, of the polygons. And I can do this by using a node that is called centroid. It is called, now I forgot it, sorry, centroid, extract centroid. Yeah, that's it. So extract centroid, that's what I want to use. By default, it doesn't do much because it tries to find some pieces that are defined by a name attribute, but we do not have this on our Platonic. So let's change that and let's just go to primitives. And you see, if I template my Platonic, that it now created a point on the center of each primitive of each face. And that's pretty good because this is exactly what I want. I want to copy tubes now. You could also copy spheres or whatever you want. You can experiment here and feel free to have fun with that. But in my case, I want to copy some tubes to that. So let's add in a tube again. And let's change the settings a tiny bit. So let's make this again 24, maybe 24 columns. Let's change the radius here down to something like 0.25. Let's create caps actually. And let's use a copy to points. So with the copy to points, we can now copy our geometry to these points. The only problem that we got now is that the alignment is not right because we have no normals. If you take a look at our Platonic and middle mouse click, you see we only have a point attribute but no normals. The normals is the direction. So we have to create a direction normal of our solids, of our faces here, of the primitives. So first of all, let's just create some normals on our Platonic directly. So let's bring this in here. And you see, if I activate this visualizer now, this will create vertex normals. But we do not want to use vertex normals. Actually, I created the wrong node, sorry. I want to create a normals node, not a soften normals. And by default, as I said, this creates some vertex normals on the vertices. But I do not want this to be on the vertices. I want this to be on the primitives, actually. So the visualizer doesn't change right now, but now these normals are actually calculated on the primitives. That's what I want. Now I can come in here and I can say that I want to transfer attributes. So let's actually transfer the attributes here. And if we activate this now, you see that the orientation of our, let's turn off these visualizers, of our tubes changed. If you want something like that, then this could be a starting point. But in my case, I want to change the orientation of my tubes so that they face along these normals. And therefore, I just have to change the orientation from Y to Z. So this is always something that you can keep in mind. If you want to copy some things onto points that have point normals or directional normals, then orientate your objects along the Z-axis, because then the orientation will be all right. Good. So you see what we have got here now. This is our object that we have, and that looks actually pretty funny. But we can make this a bit more interesting. So let's say we want to decrease the radius here on top a little bit. So let's decrease this a tiny bit. Let's increase the radius on the bottom here a little bit, something like that, to create a bit of an interesting shape here. As you can see, let me actually select this, then you can see it a bit better. And let's maybe increase the resolution or the columns of our cylinders or tubes a little bit more. And now we have this very interesting shape. Now, to turn this into a smooth, abstract 3D object, again, we could use our volume modeling workflow, but I want to show you another option that you have in Houdini. There is actually one node that does more or less all of that I showed you before, how to do it manually, automatically. And this is called Remesh to Grid. So let's add in the Remesh to Grid node here. And by default, if you activate this now, you see what it does. And let's press Shift W to activate our wireframe. Right now, it created a very ugly version of our model, but this is of course because the division size, the resolution is too high. If I set this lower, like 0.02, you see that we get a very smooth thing here. Of course, we get the problems with the edges as we had before, that these workflows do not like hard edges. And you can now do some smoothing directly here on the Remesh node. So if we smooth this, you see we get something like that. And this already looks way nicer. Now, there is one quite interesting thing here. It says VDB smoothing. So this basically really does a very similar operation than I showed you before. If we enter this Remesh to Grid, you see that it is actually doing a lot of stuff, but it also is creating these VDBs here, VDB from polygon, converting them back and reshaping it, smoothing it. So it's a bit more complex and complicated, but actually the operation is also volume modeling. So if you use this Remesh to Grid node, you are basically also using volume modeling. So how can we change the resolution of our mesh in this case? Because yeah, we can change this division size, of course. So this is an option that you have. Then you will get bit of a smoother result. But of course, you also will lose a lot of detail. So we have the option here to use this adaptive mode, as you can see here. You can, by the way, also do this in the convert to polygons node. Let me quickly show you this because I didn't show you this before. So right here on this convert node, you also have the option to use this adaptivity. This usually doesn't create a very nice topology, but in case if you need, you can save some polygons. So you see with a value of 0.012, I can save some polygons. So now it has about 28,000 primitives. So let's set it back to 0. Let's take a look how much it has now. Yeah, now it has 34,000. So you can save a bit of polygons using this adaptivity mode. Let's go back to our Platonic. Let's take a look how we can play with this. So in this case, it doesn't make that much sense. So we will leave it at 0. And then there is another option that is called project to original. And if you project this to the original, you see that it will try to keep the shape as good as possible. And you can do some smoothing that is usually a little bit less harsh than this smoothing down here. So with the combination of these two sometimes you can get quite nice results without blowing up your resolution too much. So as you can see here now, this already looks quite fine. So this is a very nice result. Now, there is an option that I also want to mention, and this is called the Exoside Quad Remesher. The Exoside Quad Remesher, let me quickly add it here to my scene, is a plugin that is not included in Houdini, but it is installed when you install the Labs tool. And it's not free. You have a trial version that is, I think, 30 days, and then you have to buy a license. But I want to show it to you because I think that it is very useful in some cases. So I used it for 30 days and then I bought it immediately because it is so useful sometimes when you just need a nicer typology than you can get out of these workarounds with volume modeling, with remeshing to grid and all that stuff. So let me show you how this works quickly. Before I do that, let me actually make this also a little bit more interesting. I want to do the same thing that I did before. I want to turn this Platonic object now into tubes. So let's do that quickly. Let's just copy all of these nodes here over. Let's go to our tubes here and let's set the radius down to 0.1 on both here. Let's increase the height a tiny bit. And now let's take a look what we have here. And you see now this is the result that we get here. This could already work. Now again, do boolean operation, boolean, and subtract these two. So let's take a look whether this works. Doesn't look too bad actually. So I hope that this is not creating anything unexpected on the inside here. Oops, sorry. Let's just reposition that. So to make sure that this is not creating anything unexpected on the inside, I will quickly use a clip node here. And with the clip node, you can just cut your object along a plane and take a look inside. And you see, yeah, this is exactly what I don't want. So something like this here is not too good. So we do not want any holes here. I think it's actually not a hole, but this could lead to some problems. So what I want to do now on these tubes is that I just increase this radius slightly, and maybe this will fix it and will create a bit of a nicer typology here. I think this will work now. Okay, so we do not need this clip anymore. I can just remove that. And let's plug this into our remesher now directly, so the output of our boolean. And let's zoom out and let's take a look whether it worked. And you see, yeah, it did work. So it looks really not too bad. And now we can just go to the quad remesher and let's take a look. A little bit of smoothing is good in this case. So yeah, maybe I will just turn even lower this resolution a bit so that we get a bit of smoother and sharper edges in this case. And I will leave it as it is now. And you see what I have now. Now I have around 353,000 polygons or primitives. And this is really a lot. So this is where it gets a little bit difficult for something like this shape. Yeah. So this is probably not the way how you want to create something like that. But if you have the Exoside Quad Remesher, this is a really, really useful tool in these cases. So let me show you how this works. First of all, before I connect anything here, I want to turn off AutoCook because otherwise it will start calculating after I connect something, but I want to set it up first. The first option that you have is the target quad count. So this means a target number, how many quads you want to create on your mesh. And in this case, we need a little bit more because this has inside faces and outside faces. So let's aim for about 20,000 for now. And this is also an object that is actually symmetrical on all of the axes, as you can see here. So it is really symmetrical, and we can use the symmetry axis in this case. This will give us a little bit of a nicer typology. Now let's link this up, and now I can press Cook Now. And now the quad remesher will start remeshing. And depending on your mesh, on the base mesh, this can take a while, as you saw now, but you see that the result is actually pretty good. So in this case, we have some weird things happening here. And I think that this has to do with probably the resolution of my base mesh. So let's go back in here, because here we have also some problems, as you can see here. So let's go in here and let's actually really smooth this out by one iteration. And let's activate the Exoside Remesher again and cook it again, because this should now really resolve these problems here. I think that these hard edges here and these typology problems that we had, should now be gone. You see, now this is a really, really good typology. Now you're able to select edge loops here. You could create some creases or whatever, and you can also create some very nice UV layouts. So this combination of workflows together with the Exoside Quad Remesher is very, very, very powerful. And I also mentioned the Quad Remesher in my Fluffy Pillow tutorial, because there I also used it. So definitely a tool worth to check out and to add to your arsenal if you need it. Now, as a last step, let's go to our Platonic. Let's add in a match size here. So let's add in a match size and let's scale it to fit inside my box, because then it is in the same dimensions as our other objects. And you see now I created 3 of these objects. So again, I want to invite you, if you want to have the other 97 objects and want to use them and you don't want to spend days creating them, then feel free to go to my Patreon, and I would really appreciate it if you support me there. You can also access all my video tutorials, my Vellum Playground course, where I cover all the aspects of Vellum. And of course, you can get this pack here of our 100 models. If you don't want to support me on Patreon, you can also get it on Gumroad. Okay, so this is it for this tutorial. I hope that you learned something. Thank you very much for watching, and I really hope to see you soon. Goodbye.